Welcome to qnawire.
Here in this problem, there are two parts of the question, and in the A part, we have to find out how much work is done on the steam for the given condition, and in the B part, we have to calculate the change in internal energy of the system. So first of all, we're going to solve the A part. So we are given that 1 mole of water at 100 degrees Celsius, it boils and becomes 1 mole of steam at 100 degrees Celsius. So the number of mole is given as 1 mole, and the temperature of water is given as 100 degrees Celsius. That means 373 Kelvin, and it becomes 1 mole steam at the same temperature 373 Kelvin, and the pressure is given as 1 atm pressure, and it will be equals to 1.013 into 10 to the power 5 Newton per meter square. So since the pressure is given as constant, the process is happening at a constant pressure. That means to calculate work done, we can use the formula of constant pressure process. So W will be equals to minus P delta V. So P will remain as it is, and delta V is V of steam minus V of W. And we have to assume steam tube and ideal gas, so we can use ideal gas equation. So by using ideal gas equation, we can write PVS is equals to nRT, where N is the number of mole and R is the universal gas constant and T is temperature. So we can plug the values here. So N we are given with 1 mole for the steam, and R here is universal gas constant. Its value is 8.314 joule per Kelvin mole, times the temperature is 373 Kelvin. So from here we'll get the value as 3101 joule. Next we'll be calculating the value of PVW, and here VW is for water. So we can do one thing. First of all, we're going to calculate the value of VW. So VW is volume, can be written as mass divided by density, and mass can be written as N times the molar mass divided by density. So by using this formula, we can write PVW is equals to P times N times M divided by rho. Now we can plug all the values. So pressure we are given as 1 atm, but we need to convert into in Newton per meter square. We have to write in this unit. So we'll get 1.013 into 10 to the power 5 Newton per meter square, times the number of mole here is 1, and the molar mass for water is 18 gram per mole, and the density of water is 10 to the power 6 gram per meter cube. We have to take the density in grams so that it can be cancelled out. So finally we'll get the value of PVW after solving as 1.82 joule. So the equation for work was minus PVS plus PVW. So you can plug all the values here. So here it was 3, its minus sign is there, so 3101 joule, and PVW is 1.82 joule, so 1.82 joule. So after simplification, we'll get 3.10 into 10 to the power 3 joule with negative sign. So work will be equals to minus 3.10 kilojoule. So this was the answer for the A part. Next we'll be solving the B part of the question. So in the B part, we have to calculate the change in internal energy of the system of water and the steam as the water vaporizes. So for that we have to calculate heat first. So heat will be equals to, this is LV, this is latent heat of vapor times change in mass. So latent heat of vapor is 2.26, it's 2.26 into 10 to the power 6 joule per kg, and the change in mass was 18 gram. So if we convert 18 gram into kgs, so we'll get 1000 gram is equals to 1 kg. So we're going to solve it and we'll get the value as 40.7 into 10 to the power 3 joules, which will be equals to 40.7 kilojoule. Now we're going to use the first law of thermodynamics, according to which change in internal energy is equals to Q plus W. W we have calculated in the A part, and Q we know, that is 40.7 kilojoule, and the value of W was 3.1 minus 3.1 kilojoule. So after subtracting these two numbers, we'll get the result as 37.6 kilojoule. So finally we can conclude the change in kinetic energy is equals to 37.6 kilojoule. So this was the final answer for the B part. So I hope you got the problem. Thank you.